questions, then let's take a look at the next part. Turn to your notes, please. The quiz that you got back, and if you really struggled with that quiz, you have an option, and I put that when I put the grades in, that you have an option to come in and see me and possibly retake that. But if you have not done A7, that's really not an option. And so I need to see all your work, and you have to be prepared. But if you didn't do that, and there's some of you that still are not getting much homework from you, we need to get that done. So looking at inequalities, this is really review that you guys did last year. So we have our inequalities, we have equal and not equal, we have greater than and less than, and we have greater or equal and lesser equal. Sometimes you might see a phrase that they use mathematically instead of greater or less than. They might say, I'm going to have you put that underneath for me. They might say, Caleb, you want to put that underneath for me so I don't trip? They might say something like at least or at most. Please don't do that anymore. Thank you. So when we are looking at these, one of the things is you always have to decide with our inequalities is we're making a graph, and it's usually graphed on a number line for our solution. And when should we have an open circle and when should we have a closed circle? And I want you to write up above the greater than and less than. This is always going to be our open circle on the graph. And the reason right below that we have an open circle is that the number is never part of the solution. The number is not part of the solution. Write this right in your notes on this page. The number is not part of the solution. Thus the reason for the open circle. So anytime you see an open circle on a graph, sometimes we're going to graph our inequalities linear ones. The open circle is because it's not part of the solution. When you have your closed circle, right, the closed one, the reason it is a closed circle is because of the equal. That number is part of the solution. It is always part of that solution, okay? And the other thing I want you to put up here, it is very key that when we look at our problems that you are always putting, as we look at these, we want to make sure that we always put the variable first. So anytime we are looking at these, we always want to have our variable. Then you're going to have your inequality, whatever that inequality would be. And then you will always put the number. And if you set it up this way, you will generally always graph it correctly. Variable, inequality, number. And when you look at the expression, like this one, it's kind of nice. It says, well, what numbers make this true? So without solving it, can we pick numbers that make it true? Is 2 going to make it true if x equals 2?
No.
No, because 8 is never going to be less or equal, so x equal 2, no. Because 8 is never less or equal to negative 8, right? So how about 0? No, x equals 0 is not. What kind of numbers do we have to be working with, Lucas?
X equals negative 2.
I could have negative 2 if x equals negative 2. X equals negative 2, it's exactly. Negative 8 is equal to negative 8. So can I have negative 3?
Yeah.
Can I have negative 7.249638?
Yes.
Yes. And if you were going to solve this, if you remember from last year, you would have simply divided our division property of inequality now instead of equality. And you would have said x is less or equal to negative 2. And if I would have asked you to graph it, we would have put at negative 2 an open circle or a closed circle because it equals negative 2. And everything below that. Now, if you always put your variable first, the nice thing is that the inequality points the same way as your arrow should always point, okay? And I am going to have you put it, your arrow above the line. I know Mr. Roth, sometimes he's like, no, you can put it around the line. I need it above for me, okay? So I'm just gonna tell you that. Everyone that had me last year already knows that, but for those of you that are new, okay? So here again, they talk about that open and closed, right? Open is always with the greater or less because it is not part of the solution. The closed is with the greater or equal, less or equal. It's part of our solution. Pretty simple ones today. You're getting x by itself. You're adding 15. We get x is greater than 3. we go to positive 3, and again, I'm going to have you put your arrow going above. That means if we're writing out our answer, it's every number that is greater than 3. So please, on your paper, do this one. What do we have to do to get m by itself? Check with your shoulder partner, and please solve this, and then we are going to make the graph. Okay? Okay? So do it right now. And I think a lot of you have talked to me that we're planning to do the retakes, and you've made plans for getting that done, so just make sure you don't forget if that's the case. So, Natalie, what did you do first? You added
7.3.
and got for a solution what?
I got
All right. Maria, you got it? M is less than 9.7. So on my graph, I might have 0 way over here, and then I might have 9, 9.2, 4, 6, 8, and I might have 10, right? So that I can see 9.7, because here was 9.8, and oh, 9.7 is here. Do I have to have my graph broken down this much? No. Could I have it even from 9 to 10 so that I can see every 10th? I could do it that way also, right? I'm going to see your inequality and then your graph, so I'll be able to see if you're in the right spot, right?
So by above you.
So you're putting your line, so this inequality, so I can see it above that,
Okay.
not just on top of it. But some people do it right, like this one did, right on top of the line. To me, that's hard to see when I'm correcting.
If we like this, if it's like a really like.
So you're going to be able to see. So like this one, I don't want it like this on the number line. I want you to go above and then just put it, just an arrow going above it. Sure, you could do the highlighter. Just do the highlighter right above it, right? There you go. All right, so we're solving this next one, right? So as we start solving this next one, Anna, what are you going to do? -5 on both sides. Now, this is where some people go, oh, you know what? She always said we want variable first. So I'm going to rewrite it first and put variable first, okay? Variable, right? Then our inequality, then our number. So I don't care if when you look at this, you could subtract 5 right away, right? And I will have other people that will say, you know what? I don't want to subtract 5 right away. I want to rewrite this as g plus 5. What would I have to put? Less or equal or greater or equal? I'm looking at. What do you think I'm looking? I would have to keep it greater, right? It was open towards the 5. I still got to keep it greater, open towards the 5 equals -3. So I don't care which way you do that, but in this case, I would have -8, right, is less or equal to g. And someone said, well, what if we don't like rewriting and put the variable first? Here's probably the most common mistake that all of students make. We know it's a closed circle at -8, right? And so now, when it's written like this, people will put this arrow. Oh. And if you were going to check, like -10, right? So if I check this with -10, and I say g equals -10, then that means, you should have this on your paper, that -3 is less or equal to 5 plus -10. That means -3 is less or equal to -5. -3 is right here, -5 is over here. -3 is never going to be less than -5. This is a false statement. And by doing just a real quick mental check right away, I can see, yeah, I can't put it this way. But if I plug in 0, right, you agree that -3 is greater or equal to 5, right? That makes it true. When I check x equals or g equals 0, it makes it true. So the way that my graph needs to go, so what I will ask is that you rewrite it as g is greater or equal to -8 for your final inequality. Put the variable first, so that this is pointing in the same way as your solution, okay? Okay? If you put the variable first, the inequality points the same way as your arrow, okay? So, it says to solve inequalities by multiplying and dividing, you do the same operations, both sides, as the addition and subtraction. Only one big exception. Warning, when you multiply by a negative, you must reverse that inequality. So it says, why is this the case? Well, we know that 3 is less than, if we are looking at it, 7, or 7 is greater than 3. And if you multiply them both by a negative, They are not in the same order, and -3 is actually larger than -7. So what that means for you is you reverse it. If it's a greater than to a less than, a lesser equal to a greater or equal, you're always changing that inequality. Okay, that's all that means. So here's the problem. You're solving at the top of the next page. X divided by 3 is less than -2. The opposite of dividing by 3 is to multiply both sides by 3. Why did they not change the inequality? Why not? Abby, why not change it? We have a negative in the problem. Why not change it? And we're multiplying. Why not? What did you multiply? What did they multiply on both sides? 3. 3 is what kind of a number? Positive. It's a positive whole number, right? Positive number. It's positive integer, positive whole number. We multiply by 3. We are not changing this. It stays exactly the same. Only when you multiply or divide by a negative. And here's my hint when you look at this practice. Anytime you have a problem like this, remember you can rewrite it on your paper, and please do this right now and put y divided by -3. Put that negative with the denominator, sometimes with the numerator if it's a fraction, and it is greater than -2, right? So y divided by -3 is greater than -2. So please multiply on both sides to show. And we're actually not, the inverse of dividing is to multiply. So we should have been multiplying by -3/1, right? Do I have to put -3/1 on this side? No. So Piper, we're going to multiply. These cancel, and I'm left with y is greater than 6. So I go up here and I go to 0, and I plug in 6 is going to be over here, and -6 is here. So just a real quick check. If y is greater than 6, that means that if I plug in a multiple of 3, what multiple of 3 greater than 6 do we want to check? 9 or 12? So let's check. If we check and we put in y equals 12, and I look at the original problem. The original problem was -12 divided by 3. Is it greater than -2? You're shaking your head yes, or you're like, no, no way. This is -4. Is -4 greater than -2?
No.
No. What did I do wrong? Negative times negative is positive. What did we do wrong? Look at the problem. What did we do wrong? Lauren, what do you see? Don't want to erase everything because I know I did the work right. Well, multiplying by the reciprocal, since it was division by -3, we can definitely multiply by -3. Maria, what do you see? We didn't switch the inequality. It's that easy to miss switching the inequality. But by doing this check and knowing that this is a false statement, I know it can't be greater than 6. Oh, I just go back here and I erase this and I change it to less than. So if I'm thinking less than 6, that means if I put in right, it should make it true, right? Because at 6, we said it has to be less than, not greater than. So if I put in 3, and I'm checking with -3/3, that equals -1. Is -1 greater than -2? That is a true statement. And so my answer, the graph needs to be going in this way. Does that make sense, how you're going to look at those? Do not just assume. And some of you, it's like every time, and I'm just like, oh, on the quiz and on the test, I'm like, oh, really, they didn't put the inequality. It's so easy for every problem you've done in this unit to do a check. Do the check, do the check. Just get used to doing a check of your numbers, okay? So we're looking at that next problem. They have -9 times y, which they divide on both sides. The inverse is to divide by -9. And notice it started with a lesser equal, and once they put that division, they changed this to a greater or equal, okay? So they graphed it, again, closed circle, going to the right. So in this one, we are going to finish the problem by doing what on both sides? Divide by 7. Should I flip the inequality? Oh, wait, no. It's a -2. The number we divided by is not negative, so you keep it, right? We have it in the right order. So if I was looking at this problem, I might put 0, And then I might leave, how many spaces till I get to 1?
7.
7, right? 7 is -1. Why do I want to go that many? Because I want to show -2 sevenths. Right? Here's -2 sevenths. Oh. And it goes like that. And then I might go up this way 1, 2, 6. And that's going to be my positive, right? So that I'm seeing that this is my -2 sevenths, right? So inside I like to change it to a decimal. Why wouldn't you? This is a nice decimal to graph, or nice fraction to graph. Don't change it to the decimal. All right, so to undo multiplication, normally we divide. What about our fractions? What should I be thinking of multiplying by? Sam? For what? What is, well, I could multiply just by 4, but then I still got that -3 out there. So, I'm going to go with, what did you say? -3/4. So, if we are looking at this, remember, and if you have your calculators, definitely, you can divide it, but generally, the best thing to do is to multiply by that reciprocal. So in this case, I am going to multiply by the reciprocal of -3/4, which is -4/3. Again, my hint would be put that negative either with the numerator or the denominator, this negative that's out in front, so that you think of it as going with one of them. And I don't care if you put it in the denominator or the numerator. And a lot of times my recommendation is the denominator when you have a fraction, because then that helps you to remember I multiply by a negative, gotta flip it, right? And I have 3 times -4/3. And this is really nice on this side, and this is why I sometimes put it in your calculator. I mean, 3/3 is the same as 1. And we are left with -4 was less or equal to, what's that, p, so p is less or equal to -4. Does it make sense? Pick a multiple of 4 that is less than -4. So like what? -12. -12. So if I think of -12, and I take that times -3/4, is that going to be greater or equal to 3? Because that's what my problem said, right? -3/4 times p. So 4 goes in here, and I end up with 3, and negative times a negative is 9 greater or equal to 3? Yep. So when I'm looking at my graph, and I have 4 over here, and I have -4, at -4 and maybe -8, I have a closed circle at -4. Now, I am not going to be so picky that, like, this is exactly 4, but when you put your number line, my hint would be you do not have to have a ton of these dash marks. I would simply put 1 at -4, I'd put 1 over at -8, 1 at 0, and I should have at least 3 numbers on your number line, right? So I can reference it. Does that make sense? Yeah. I do not need a ton of little dash marks on yours, okay? So, looking at your assignment, what I mean is that I only need really 3 on here for you to reference for me, okay? So back on page A9, okay? So, I need really 3 of them. Here's one of the first things where I had people making some mistakes. Number 5, you have 4 is less than -p/2. If you wanted to keep it in that exact same order, could you rewrite it and put 4 is less or equal to p divided by -2? This is where I'm talking about placing that negative that's out in front with your denominator. Seems to make the problems a little better. Again, could I have started either 5 or 6 and rewrote them and put the variable first? I like to put my variable first because I know my answer. I want the variable first. So I put Jacob -6c is what? Same problem, I just want to put the 6c first. Yes. And now I'm going to still go through and solve it, but now I have the problem in the correct order. I have had people when they were looking at 7 and 8 say, you know what? It says write this inequality and then solve it. And they've left their answer at the bottom as like x is like greater than something or x is less than, okay? And they said, is that the answer? Well, you didn't answer the question. The question said, how many more toys do you need to meet the goal, right? So it's like a sentence. We need at least this many toys, right? So you can use the words, you don't always have to use less than or more than, we need more than this number. You can say at least.